This is question 17 from the GATE 2016 Session 2 EC paper, where we are given this sequential circuit and the output of this OR gate is connected to a resistor of 10 kilo ohm. We are given that the supply is 5 volt and that the D flip-flops are initialized to this value. We are asked what is the average power dissipated in the resistor. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. A little bit of background. There is a positive edge triggered D flip-flop is one where whenever you have a positive edge on the clock, whatever the value of D was at the moment of the passage, Q will take on that value until the next passage, at which point it will sample D and take on the value till the next passage, and so forth. So we know that if you have a series of D flip-flops that are connected to each other with one Q driving the next D, this is a shift resistor. And since the MSB or the outermost flip-flop output is connected back to D, this is a circular shift resistor. So all that's going to happen is the data is going to be shifted circularly in the clockwise direction. And by clockwise, I mean like that. So let's say at clock equal to 0, it starts off at 0, 1, 0, 1, 0 as the problem says. Well, then what is the value across the resistor going to be? Well, it's going to be Q3 or Q5. That is the OR of Q3 and Q5. So it's going to be logic 0, which is 0 volt. At the first clock edge, you have a right circular shift, which is 0, 1, 0, 1 and 0. Right? All of this will become all of this, and this will come here. That is a right circular shift. Now both Q3 and Q5 are 1, so the OR is 1. So the resistor has 5 volts across it. Similarly, we can populate the table. This is 0, 0, 1, 0, 1. This is 1, 0, 0, 1, 0. This is 0, 1, 0, 0, 1. And this is 1, 0, 1, 0, 0. Right? We're back to the initial state after 5 clock pulses. And over here you've got 0 or 0, Q3 and Q5, 0 or 1, Q3 and Q5, 1 or 0, and 0 or 0. Right? So out of 5 clock pulses, for 3 of them, you've got a 5 volt across the resistor. Well, that means that the average power is going to be 3/5 of the power in each period. The power in each period is going to be V square by R, which is 5 volt square by 10K, and this whole thing approximately equals this whole thing equals 2.5 milliwatt. We require the answer in milliwatt. We require the answer in milliwatt, and so this is 2.5.